Hello, everyone. Good morning or good evening.
Hi, sir. Good evening.
Good evening.
Hi. Yes, sir. So, how are you people? How things are going on? We are in Docker model, right? So,
Hi, Loksai.
yeah, hello.
Yeah. May I ask something if you are free?
Sorry, I'm not free. I'm on this session now.
Actually, that is in relation to this session.
What's the question?
Yeah. So, what I was asking, yeah, how to create Docker images? There are two steps to create that, right? One is Docker commit, and the other one is Docker build. And I was going through your yesterday's recorded session, in which you mentioned that the Docker build will be used by the developers.
Okay.
So I practiced Docker commit, which was successful, but later I tried to perform the Docker build as well, in which
Mhm.
I found difficulties to perform the Docker build.
So, what is the error? Possible reason for that issue?
Yeah, I took the screenshot of that error message. 1 second, let me open that.
What's the error message? Can you read out?
Yeah, 1 second. Uh, yes, the error message says the legacy builder is deprecated and will be removed in a future release.
Come again?
The legacy builder is deprecated and will be removed in a future release.
Is that error or warning?
Uh, it's written in yellow, deprecated, bold letters, and then this error message. Docker build
Mm.
requires exactly one argument,
Yeah,
something like this.
yeah. So, please check the syntax, okay? Like, there is some issue with that
You know what
command.
happened? Actually, I typed vi docker file, and then I write all those steps which you mentioned in the GitHub repository, like
Mhm.
from base image ubuntu run apt. Once you pasted in the, I was looking at in the recorded session, you when you pasted that under the vi editor,
Mm.
everything was pasted in a sequence, one under the other. But when I pasted it from ubuntu, was starting from the left, extreme left, and then run apt, run install, run git, all that stuff was in the middle. They were not going on to the left. I thought that is the reason.
See, point is you have to maintain the statements properly. Okay. Before you prepare this in your notepad, just maintain the alignments here properly. You have to copy the exact number of characters. Instead of
uh,
that, if you copy something like this, I think you must have done like this, right? Copy
yeah, yeah,
cancel.
yes,
So,
yes.
which is having some leading spaces here, which will
Oh.
get which will be interpreted as a blank space in your VI editor.
Hmm.
So copy the lines. So how I did is I just copied only the exact number of characters, right?
Got it. Yeah. So this is my issue. I got it
So
now.
this is how I copied actually. So I can copy
Hmm.
only the selected number of characters from there and it should be fine.
Got it. So what I will do is I will align them first on
Hmm,
the left
hmm,
hand side, extreme left, and then I'll copy it.
yeah.
Got it. All right. And yes, and one more thing, this will be performed by the this Docker build will be performed by the builders. Sorry, I'm sorry, builders, developers.
Mm, okay.
No, I'm asking it.
Yeah, that's what this Docker file will be in the source code repository, right? I will show you, okay, how we can able to manage these entries in the source code repository and enhance our CI/CD pipeline.
Okay.
So, Sai,
Yep.
I have a doubt regarding this Docker binding,
Mm-hmm.
network binding. Yeah. See,
Yeah.
when I'm performing that, actually, see, I performed using Tomcat,
Mm-hmm.
Docker run -IT -p
Mm-hmm.
8080 colon 8089. Okay. Tomcat,
Okay.
Tomcat colon 8.0. Okay.
Okay.
And even in EC2 instance, I made all the ports open in
Okay.
security. So I'm
Mm-hmm.
not getting that page. I'm not getting that page. It is first comes container port, then comes host port, right?
No. If you can see the syntax here, we use
Yeah, yeah,
the host port followed by the container port.
yeah. But see, in the Docker run,
Hmm.
this is the other way, right?
That's okay. See, port number can be anything. No, like see, in your Docker file, you can able to expose and change the port number, right? It is not mandated that it should be 80. Initially, your Tomcat might be defined with 80. That doesn't matter. Got it? So when you try to interpret the value, you can able to pass anything. That is the reason, even if you notice in my case, I have enabled all the ports, right?
Yeah, yeah, yeah.
So if you're
See,
not doing
for
that,
me,
in that case, what you should do means you should exactly pass this value. So this is your host port
yeah. No,
and
no,
this is your
Lokesh,
container port.
correct.
Got it?
When I did this, it is executing actually.
So in your
It is
case,
not.
you can able to maintain like because I just given the list of port numbers, right? So
Yeah, yeah.
your container will run Tomcat container will run port 8080.
Okay, 80,
So
80. So it has
yes,
to be this side on the right part,
as per the
right
syntax, this
side
is what
part.
first you should enter your host
Okay.
port number and then your
Okay, yeah.
container port.
No, no,
Correct?
no. Actually, I saw this example, right? 8080 is first and then 8089 is second, right? So only that was in my mind. That was in my mind
Mm-hmm.
when I executed
No,
that, it
no.
was failing.
Okay, my point was like at any point of view, you can able to change the numbers, right?
Okay, okay, okay.
Yeah,
So host port is first, then comes container port.
yeah.
Okay, got it.
You can follow this syntax here: publish -p host port colon container port.
Container port.
Yeah, and looks like continuing with the same. If let's say if we don't allow all traffic
Mm-hmm.
on the VM AWS VM,
Mm-hmm.
and we can mention any specific port number as per our choice over there.
No,
So how we will recognize that what should be the port number on the VM as a host port?
as a as a user, developer, or the testing team who's trying to run that application,
Uh,
they should know what are all the ports they want to use. All right.
that port number we have to mention there.
That port number has to be updated in the security group of that instance.
Okay.
Got it? And
Okay.
that list will be provided by the infra team. Like for example, in our case, we just enabled all the ports because it is our own server. It's a dummy server.
Hmm.
But in real-time environment, your infrastructure management team, they'll be providing you some range of port numbers. Only that range of port numbers, you'll be using it for your testing and enabling your services. Got it? For some
Got
security reason.
Hmm. Clear.
Got it?
Yes. Yes.
Fine. So apart from that, are we good with this Docker file instructions? What is from instruction? What is run?
I'm having one question. That when we are creating volumes, host volume and container volume, we you are using the same name PL volume 1 and volume 1. So we can have to use the same name, different name can be also there for the container.
It, see, it can be anything. It can be different, no problem.
Acha.
So we are just mounting that path, right? Mounting your host path with your container path, container volume. Where is it?
Yes.
Yeah, here somewhere we discussed, no? Yeah. So it is just a process of mounting your source volume, your host volume with your container volume. So this volume directory, it can be anything.
Okay.
So any other question from anyone? All good?
Yeah, so far, yes.
So what are all the various instructions we have used? Docker file instructions. Please have a look and try to recollect the points. From instruction, run instruction. So developers, whenever they create any Docker file, they will be starting with the from instruction to identify the base image. Like how we used Ubuntu or Tomcat, right? So the base image should be identified. And then we can use copy to copy the files from source machine to your container volume.
Last day notes was not updated in Git repository. This note.
Come again, come again. I missed your question. Come again.
This note was not updated in Git repository.
It's already there, ma. Like,
No, now I have seen. I have seen just.
can you please refresh the page and see on the date in front of you? I just took all the things, right?
Yes.
No, Loksai means you have not updated that repository. So that's why we are facing some issue from.
Today it is there, but on that 4th of March, it was not updated.
Okay, please refresh and check it out because I can see it is available there. Okay, anyways, any other question? You all able to access the notes, right? Or any issues? Or you want me to share the link again?
No.
We
We
are
can
able
able to see right now. Yeah.
Right now,
Oh,
it is all right.
okay.
Yeah, day before yesterday, the update branch option was not coming up there.
Mm-hmm. Okay. So we can close or refresh, should work. Fine. So now, the next item in the list is we'll be working with our Docker Hub registry. So we'll see how to publish our changes to the target repository. And from there, we can deploy to target environment. And we'll be discussing about the container orchestration tools like Docker Compose, Docker Swarm, and promptly we'll be focusing on Kubernetes. So this is an agenda for today's session. So here Docker Swarm will be having the overview of Docker Swarm. And then we'll be discussing about Kubernetes in detail, right? Just a minute, let me log into my node.
Dosa, is Kubernetes a component of Docker, or is it completely a different entity?
Yes, who's there?
Yeah, it was me, Loksai. I just want to ask if Kubernetes is Kubernetes is the component of Docker or not, or is it a separate entity altogether?
It is a kind of container orchestration tool.
Container orchestration.
Okay. So we'll be talking about container orchestration. As part of that, we have Kubernetes, which is promptly used. So how things are going on, guys? Are you able to see some progress in your learning, like compared to day one, and today it's 24th day, correct?
Yeah.
So can you able to gain the confidence?
Uh, yes, to be
Yes.
honest, Loksai, from the day one, if I consider myself on the day 24th, it's I can see that I have increased my learning. But to be very honest, it requires a lot of practice. If
Oh,
whatever you have taught us so far, let's say you have almost completed 6 or 7 modules, along with Git, Linux, overview of DevOps and all that stuff, Ansible, Jenkins, Docker.
yeah, certainly practice is required. And apart from that, right, let's say it is not just about practice. Let's say today we are completing a Docker module, and tomorrow if you practice everything means that won't be sufficient. Okay, you should have a regular revision of the topics also.
Yeah, this is the problem
So
actually.
please do revise the content, because market is really good now for DevOps resources. We have a requirement for a lot of freshers in the sense the trained DevOps resources. So once you
Correct.
people complete your training, you all will be considered as a trained DevOps resource. If you upload your profile, you'll be getting a lot of openings there. Okay, opportunities there. So I strongly recommend once you complete your Kubernetes module, you are ready for your job market. All right. I'll talk about it. Okay. Once I complete Kubernetes, I'll show you how you can able to groom yourself for your interview preparations and other stuff. But I strongly recommend please revise the content, because today we are in Docker module means you should able to recollect all your Linux commands, which we done in Linux module. Also the
Mhm.
Git commands, right? And also Jenkins, how you can able to independently work on it. So please revise the content, because once you upload your profile, right, you'll be getting some interview calls, and it's not possible to do the last minute preparations and all. Correct. So till you get your position, please r- revise the content, make yourself comfortable, and have a control of the topics.
Looks like
Correct.
just one request, like I wanted to ask where we can incorporate all three modules or topics and create a small project so that it will be a revision for all three these
That is
topics.
what we are going to do once we complete Kubernetes. Okay. So once we complete Kubernetes, I'll show you how to integrate your Git, Jenkins, Docker, Kubernetes, everything together.
Okay, perfect.
Okay. And you can able to come up with a CSD pipeline also with that.
Yes, okay.
Right. So don't worry. It will be on your project perspective, like how you can able to showcase your skills during interview. Right. It is not just about learning the modules. With these modules, I've done this project, and I'm able to create an end-to-end CSD pipeline with all these topics. That is what the expectation. So I'll be sharing those things as well. Don't worry.
Okay, looks like thanks.
All right. So now the next important thing is, in our previous session, we were using something called Docker build, which is promptly done by the developers. So in order to work on this, developers have to maintain the Docker file and source code repository. And as part of your build activity, we'll be running this build command and create an image in a local machine. So once the image is ready, okay, so how we can able to access it in any other machine? Okay, how we are going to access it in any other target machine? For that, first we have to publish it to your container registry. So if I get into the build server here, like, good that I shut down the machine. Uh, uh,
And I guess looks like I have already done I won't say it a mistake, it's a blunder. What I did, I deleted all my VMs just to practice from the scratch for Linux, Git, and Jenkins. I deleted each and everything. So I just completed my Linux and Git again, working on
no,
the Docker with
no,
you.
no problem, no problem.
So I believe I need to do it again for Jenkins because that is the biggest module so far.
Mhm.
And meanwhile, you're opening this. Loksai, can you please tell me DevOps engineers and site reliability engineers, they both do the same work?
Uh, we'll talk about it in some time. Okay, this is out of the context now, so better we'll
Okay.
focus on this topic. People are listening to this one.
Okay.
So regarding your DevOps career related stuff and other things, we'll discuss in some time later.
Okay. Done. No problem.
Okay, because I don't want anyone to get distracted here.
Yeah, sure, sure.
All right, so we have a Docker. I mean, we have some images here, Docker images we have prepared on last session, right? And also we can able to access our Docker Hub, right? So I'll show you how you can able to access it. So from this, if you can see here, we have a explore option to explore the images that are already published by the global community. There are a lot of users. It can be from the authorized, service providers or any third-party users. They have published their public images. And as a user, if you want to publish any of your images, it will be published into this repository tab. So you can see there is a repository. So by default, the repository name will be same as like your user ID. If this repository is not present, click on this repositories tab and click on create a repository and enter the repository name, short description, make it as a public repository and create one. That's it. Once repositories are created, based upon the name of repository, you'll be creating your image. So that is what we did in the last session, right? So what we are going to do here is the image, whatever we have prepared here, it will be published to your container registry. Okay. So first step, build an application image. And then you need to publish to Docker Hub registry using Docker CLI command. Okay. So there is a command called Docker push command. Just Docker push followed by your image name. And prefix with your repository name. It is same as what I shared on the day. Like I use some repository name, right? In the same format, you'll be using a push command here. So this is a general syntax to push the images to your container registry. Okay. It is just to push the changes to the container registry. Now, in this case, how we can able to interact with your Docker Hub repository through your CLI command. That is from this build server, I want to communicate with this Docker Hub registry. So for that, what we have to do means, first we have to create an access token. That is Docker Hub access token. So hope you all remember, right? While working in the Git module, if you want to push your changes to the remote Git repository, we have created one personal access token. Remember?
Yes, sir.
And if
Yes.
you want to push the changes to the remote server, we use that token to enable the user authentication. Similarly, here, not only here, if you take any APIs, okay, let's say if you want to access your Docker Hub registry directly through your web browser, you can use your username and password to log in. Similarly, here you have your AWS account. So if you want to interact with this AWS console through your web browser, you can use your username and password. Tomorrow, once we start with our AWS module, we are not going to use AWS console. I'll show you how to interact with AWS through your AWS CLI commands. So whenever you try to access any external service using the CLI commands or any other scripts like Python or Groovy or shell scripts, we never use password-based authentication. It is a token-based authentication. So in this case also, first we have to create a Docker Hub access token, and then we have to log in to Docker Hub. When you log into Docker, when you try to log in, right, it expects the username and it will prompt for the password. It is access token. Right. So we need to provide the username and the access token to access that service. Easy. So how to create an access token in your Docker Hub account? That is the first point to be considered here. So let's go to this container registry. On top right, you can see your account label, right? Here you have something called account settings. Just click on your user icon and go to this account settings page. And in that account settings page, if you can scroll down, you can see something called personal access token. Can you see this page? When I click on that account settings, it took me to this page. Here I have account information, email ID, password, and other stuff, and something called personal access token. Just click on this option and you can find an option to generate a new token. Just click on generate new token and enter the token name. Like I can say PL Docker Hub PAT1 and of this token. If you say none, the token will not get expired. Hope I'm audible.
No, you weren't.
What I'm saying here is we are going to create an access token. And while creating access token, you need to specify the access token description. There is ID for that access token for your reference. And the expiry date means what is the retention period of this token? It can be 30 days or any days or any custom time frame. You can say none for now, or if you say 30 days means within 30 days, the token will be expired. And what you're going to perform with this token, access level. So when we create any token, right, using this token, I can able to read the Docker images. I can able to write or delete the Docker image into the Docker registry or repository. So you can choose all these three options. But instead of that, if you simply say read only means you can perform only read action. You can able to read that image. That's all. You cannot update it. So in our case, we are going to publish something to the container registry. So you need read, write, and delete privilege. That's it. Hope it's clear, right? Go to your account level settings, and in this account settings page, select personal access token and click on generate new token. Here, specify the access token description of your choice, retention period, and then the access permission should be read, write, and delete and generate. So once you click on generate command, it is giving a detailed description about how you can use this token. You can use this token as a password whenever you try to access it through Docker CLI. So from our local machine, we are going to access it, right? So this is what token ID and it never expires. This is a permission and it is giving a recommendation to use the access token from your CLI client. That is your local machine. And this is a command, login command. So in order to log in, first we need to enter the login command here using this username. And then once you execute this command, right, it will prompt for the password. See, at the password prompt, enter the access token which is generated here. Easy. You no need to mention it directly. Once you enter this command, it will prompt for the password. While it is prompting for password, just copy paste the content there. Simple. And before you close this page, ensure that you copy this token, because once you close it, you cannot get it back. You have to generate new token then. Any question on this process?
This
No.
username where it says Docker login -u states
User.
username,
User.
and this loci eta is already there in the Docker hub.
It is my account ID, right? This is a user
Yeah.
ID, right?
Okay, clear.
Others, are we comfortable with this?
Yes.
Okay. So now let me go to this system, and I just want to publish the image which I prepared on last day. So it can be anything. Okay. So what I can say, first I have to log in to my container registry. So when I execute this command, docker login command with the user ID, it will be prompting for the password. Just enter. See, don't enter your login password. Okay. It should be a token, whatever you have generated. Just right click once and enter. It's a hidden field. You have to right click once and enter. You won't see the value actually. Right click will just paste the content. Now the login is succeeded. Once the login is succeeded, then you are ready to publish your image. Prepared your image with your tag. You have to mention the tag there. Without tag, you cannot publish it. Let's say in our last session, we have prepared these two images. So this image was prepared without any tag. So it is assigned latest as a tag. And this is prepared with a version number. So you have to use this image name in this Docker push command. Followed by that image name, :v1.0 along with the tag. Okay, this is syntax. So any question on this command now? Any question?
Could you please explain it once again? Docker push.
It is just to push the images to your container registry. The registry, whatever you just signed in, right? Your login is active there. So when you execute this push command, you can able to see that image will get published to your container registry. Docker push followed by the image name. And ensure that you use a prefix as your account ID or the registry repository name, whatever you prepared there. In my case, it is this one. Can you see this? Loci ETA. Same way you should be able to find one thing there. Now, let me run this command. See what's happening. It is preparing the image and publishing it to your target repository. Nidhi, right? Nidhi, are you clear now? Is that okay? Thank you. Yeah, almost it's done. Yeah, it's completed. Now, if you go to your source code, what do you call this? Docker Hub repository, just refresh the page. In the repository tag, you can see there is one image published just a minute ago, less than a minute. One image got published. This is the image name which we created in our local machine, and you can able to see this is the version number v1.0. So this is the changes we made in that thing. So now anyone who wants to work on this image, you can able to see this is a public view. If you click on the public view button, this is how the image will be represented for you people. Correct. So for example, if you want to use this image, means you can search for this image name in your search bar, search Docker Hub, search this name, and you can use a Docker pull command followed by the image name to create a container in your local machine. So this is how anyone can able to deploy this image in the target machine. Understood? So it's a very important scenario. So whenever we try to publish any image to a container registry, you should have a valid container registry access. So in our last session, we were discussing about other types of container registries, like we talked about Azure container registry, AWS container registry, remember?
Yes, yes, correct.
So all container registries will be following the same process. If you want to work with Azure container registry, you'll be using Azure CLI to interact with that Azure container service. It expects a token. You have to create access token in Azure account, Azure Cloud Platform. Similarly, AWS Cloud Platform. Process same, only the interface, the environment is different, that's all. Right. So this is about your Docker publish, pushing the change to the container registry.
Without
So
tag, we cannot do the same, right?
tag is a best
and
practice, okay?
Okay.
If you created an image with a tag, you have to use a tag name. Otherwise, let's say I have created one image, the first image, which is available here. I can simply use this one. There's no problem because it is asking the latest. There is no tag assigned. So if you're not giving any image or tag number, it will try to assign the latest as a tag by default. And in real-time environment, it is always recommended to use a tag number.
So that means it's just used for the tracker, right?
Yeah, version controlling, right?
Hmm.
So
Looks like
if
just sorry.
continue. If I want to do some changes in that image, so I have to pull it to this local machine. After that, I have to create that container and do that. Again, I have to push it back.
Again, you have to use Docker commit to create an image, new image and push the changes.
Okay.
Got it? And by the time it will be having a new version of that image, the tag number will be new one.
Okay.
Got it? So it is same as like how we use our source code repository. We can make n number of commits in source code repository. We can able to publish or version control it, right? Similarly, the Docker image.
Looks like I just want to ask, like, you created these images yesterday or day before yesterday. Looks like
Okay.
ETA app build and the Java app build, whatever it is.
Okay.
And we have three more images: Ubuntu, CentOS, and Tomcat. So if I want to try it with Ubuntu,
Okay.
do I need to since the base image is already there on the Docker Hub
You
registry?
can publish it into your own repository, right? So you have to change the name of this image and you should add a prefix with your ID. You can even publish it. You cannot directly publish this image to your registry because we're not using any enterprise account. We are using a community account.
Correct.
So always you should use a prefix, your repository name as a prefix to any image.
Okay, but I can do the same with these Ubuntu, CentOS, and Tomcat as well.
Yeah, yeah. Yes, it's possible. Fine. So if you are clear with this, shall we move on to the next topic?
Yes,
Yes.
sir.
Yes.
All right. So the next important topic in the list is about the container orchestration. And here we'll be discussing about the Docker Compose, and then we'll be having the overview of Docker Swarm, and then we'll be learning in detail about the Kubernetes. I mean, as per your course curriculum. So here we have a separate module for Kubernetes, but I'll just give you the comparison, like what is Docker Swarm, what is Kubernetes, and other stuff. And let's talk about Docker Compose. So Docker Compose means it is a plugin or it's an extension to your Docker engine. Correct. It is a plugin or extension to Docker engine. Okay. And it is used to execute multiple containers as a service. Simple as that. So Docker Compose is used to run multiple containers as single service. Okay. This is a basic context. When you install Docker, right, this Docker Compose is not part of the Docker. You have to explicitly install this plugin. I'll show you how to install and work on it. But the main objective here is it is used to run or execute multiple containers as a service. Keep this point in mind. And then we have something called Docker Swarm. Docker Swarm also can be considered as a container orchestration tool, which is used to ensure the high availability of these containers which you are running as a service. All right. So Docker Swarm is to orchestration tool used to ensure high availability of the containers. Okay. So the next question will be how this Docker Compose can able to execute multiple containers as a service, and how the Docker Swarm can able to ensure high availability and all. But before that, we need to understand some important things about the deployments. So in your Jenkins module, you must have used a simple deployment process, right? Like how you deployed a WAR file into the target machine. Let's say using Jenkins pipeline, you have created an application build, created an application artifact that is a WAR file, and after thorough testing, assume that you have deployed it to your target environment. All right. So how you deployed it? By using some shell process. It can be a publish versus plugin, or it can be your SCP process or whatever. So using SSH connection, we are connected to the remote server and copied the file to the target machine. Just a WAR file. Copying a WAR file from your source server to the target server is what the deployment we made in Jenkins. But when it comes to the containerization, as we discussed already, on deployment perspective, we are not supposed to directly deploy the artifacts to the target machine. The artifacts, whatever we have prepared in the build environment, it should be converted to an image. You have to prepare one image based upon the application along with dependencies. And once the image is ready, we have to publish it to the container registry. So this is what we did so far. Now, my application is available in container registry now. I want to deploy to a target environment. How to do that? I can use a pull command in my target server, or I can use run command in the target server and run that image. It will create a container. That's fine. But sometimes, we have to take care of the availability of the containers, because if the same application, if it is deployed in the production environment, QA, it's not an issue. It is just for testing purpose, a non-prod environment. What if the container is deployed in the production environment? If you deploy an application using a container, and if the container is running in a production environment, that container should be up and running 24/7, right? Yes or no?
Yes.
Yeah, yes.
So when we talk about the containers are not the permanent entity. As we discussed already, at any point of time, containers will go to exit state. Correct. That is the reason we have a persistent volume. We have used Docker volume because at any point of time, the container will go to exit state. At least I need to retain the data in a host volume. But if the same container, if you try to deploy in production environment, then how we can ensure the high availability of the container? For that purpose only, we use something called container orchestration tool. So whether it is a Docker Swarm or the Kubernetes, it is used to ensure high availability of your containers that are running your application. Correct. There are a lot of concepts behind that. I'll talk about it one by one. But as of now, try to understand the purpose of this. Okay, so now let's see a small example about this Docker Compose. Listen carefully. In your previous session itself, I was talking about the three-tier application architecture, right? Remember?
Yes.
So what are all the layers of the three-tier application architecture? We have a front-end layer,
Front-end application,
Application and the database layer.
and we have an application layer,
Database layer.
and then your backend layer. So this front-end layer is something called as meant for user interface. And this
Business
is meant
logic.
for your business logic. And this is your database. So for any microservice, whether it is your user registration service or a user login service, definitely it need an user interface. It needs an application logic to validate the input, as well as it needs a database to store the data permanently, right? But if it is a containerized application, in that case, you'll be considering all these things as a container. So I want to make this one container 1. This is container 2. And this is container 3. So these 3 layers of your application are actually going to get deployed in the target machine as a container. So C1 is responsible for user interface, C2 for application layer, and C3 is meant for your database containers. We have database containers also, like MySQL servers, everything. Now, the point here is, assume that this is meant for your user sign-in microservice. There is a small microservice in my application, and this sign-in logic requires these 3 layers of your application. But the containers are independent, right? Assume that we have created one image, and based upon the image, we have created the container 1. And for this, we have another image. And here we have another image. So if I have these 3 images in place, how can I create a container? What is the command to create a container?
Docker run.
I can use Docker run command to create a container.
Yeah.
So if I use Docker run command to create a container, I'll be using this image name, and I can able to create only one container at a time. Correct? But when I talk about a service, all these 3 containers should be available at the same time. I cannot start container 1 and say that my service is up and running. If all these three containers are up and running, then only your service is up and running. So whenever the container is depends upon each other, I cannot run this C1 as a standalone container, right? To make this running, these C3 and C2 also should be up and running. So if you're using Docker run command, it is not possible to keep your containers in sync, because at a time only one container can be created using your Docker run command. So we cannot combine the changes to each other. But my requirement is I want to run all these three containers as one service. For that we use a Docker Compose. Can you understand now? So I'm not going to consider this as an independent container. It will be considered as one service container, or its application service. So using Docker Compose, we can able to execute multiple containers as a service. Then how we can able to create this means we'll be writing or creating a manifest file. Manifest file means a configuration file using YAML scripting. So we have to create one YAML file, script file, through which you can able to define the properties of the container. For example, I want to create one service. Means what is the name of the service? And then what are all the containers I'm going to use? If I need 3 containers means what is the name of the container? Which image the container has to use? Whether it is having any port mapping or not, whether it is having any volumes or not. So the complete property, right, of this service will be defined using your YAML scripting. So people who are new to this YAML scripting, it is purely based upon the key and values. Okay. It is a pair of key values, that's all. It is a declarative script. Remember, in our Jenkins module, we use the term declarative script, right? Similarly, the YAML scripts are declarative. It means whatever you need, just declare it. The key is used to is meant for identification. It is an identifier and it is a value. So, for example, if I want to create a service and I use a key called name, and if I say SVC1 means this is a value. This is a key and the corresponding value. And within this, I have a container means I can have a name of the container. I can able to assign the volume. I can assign the port mapping or the image name or image properties or tags, anything I can able to pass as a key and a value. But I talk about the YAML scripting in detail once we start with Kubernetes. It is not a priority now. Once we start with Kubernetes, I'll show you how to write a YAML scripts. Correct. But as of now, try to understand the purpose of Docker Compose. So what is the purpose of Docker Compose here?
Execute multiple containers.
Multiple containers as service.
As a service. So once you have this manifest file ready, assume that this is a manifest file which I have created like vi like this. So I create this manifest for YAML file and add these descriptions, for example. And once the file is ready, you'll be using a Docker Compose. Up or Docker Compose down. So this Docker Compose up command is used to start a service defined in the manifest file. This is the manifest file. So in this file, what are all the services you have defined? Let's say service 1 will get started. So when you say service starting means the underlying containers, everything will get started at the same time. All the service will be up and running at the same time. Similarly, once the process is over, if you want to stop that particular service, you can simply use a down command. Used to stop a service. You see? So this is how we use Docker Compose to execute or run multiple containers as a service. Any question on this concept? So you understood the purpose of this, right? What is Docker Compose? Yes, no,
Using
Yes.
or any confusions?
VI editor for this writing the script, right?
Yeah, we use our V editor to create a new file, and there we'll write a script, save the script. Once the script is saved, from the same path, you run a command docker compose space. Easy.
Yes. So this my web app 1.yaml is the manifest file.
Yeah, that's right.
Which includes YAML scripts.
Yeah.
Okay.
But you cannot directly work on this feature. If you want to work in Docker Compose, first you have to install that plugin. As I said, it is a plugin or extension Docker Engine. So once you install Docker Engine, you can able to install this plugin. So to install this plugin, again, we have to visit the official page. Remember, I shared one reference link, right, for official page of that Docker.
Yes. docs.docker.com.
So if you can see this page here, it's the same page which we used actually to install this Docker initially. But now we are going to use this page, install Docker Compose plugin. So in order to install this, we have a lot of steps involved. Okay. So first we have to choose your distribution, which distribution you want to work. If it is Ubuntu means based upon the Ubuntu distribution, there'll be commands. So we have to download and execute it. And there is another thing called install manually. Where is it? This is the option. So when you click on install manually, this option requires you to manage manage your upgrades manually here. And first you have to download the plugin under a particular directory of that user profile, and then you'll be manually running the command to install it. And once it is installed, you have to change the access mode of the particular Docker Compose, because Docker Compose, once it is installed, right, it should be part of your Docker group, and the access should be there to the plugin. So that access should be given there, and then you can able to execute your Docker Compose command, like Docker Compose version command, and verify the versions of that one. Right. This is a manual installation, but there is something called using your plugin manager. You can able to do that, but this is not working. If it is your open source, I don't think it will be working because it is not compatible here. This plugin, the Compose plugin, if you use this directly with apt-get, this apt-get package manager is unable to capture all these things because of the recent version changes. So we always recommend to go with the manual installation process. So this is a link. I'll put this in your class notes as well. Okay, I'll keep it here. This is to Compose. Okay. So any question on these things till now?
No.
Okay. So for the manual installation, what are things required? I just prepared a separate documentation as like with Jenkins. So I'll be sharing it now and you can able to take it for your reference. So these are things. So I just took it from your official page now, like the manual installation of Docker Compose. So first you have to prepare a folder, config folder, Docker config, and then you have to prepare a directory out of it for the plugin. And once you create the folder, there only you're going to download that repository. That is your Docker Compose will be downloaded and then it will be configured with your Docker engine. And once it is configured, then you have to change the access mode. We have to give some execute privilege to the Docker Compose. It is available in your default Docker configuration path. From this path, you have Docker Compose. To execute your Docker Compose command, like Docker Compose version or Docker Compose up command or down command, you need this access mode, right? So that's these are a very simple step. Okay. Any question? So if you want, I can execute all these things and I'll show you how to install your Docker Compose. I just took it from your document. Okay, like official documentation. If you can see here, these are things. These are commands I just copied, nothing else. Okay. So from this page, you can able to simply run these commands. It's done. Right. So these lines are complete. Now I'm going to execute this command here, chmod command. We have just downloaded the repository and configured it with the docker underscore config. And now we are going to give access to that service. So it's completed. So once this is done, you should able to execute a command, docker compose version command. So this is a command, docker compose version. See, this is the version of Docker Compose plugin installed in the machine. So please ensure that you execute these 3 lines of code that will create a directory and configure the Docker Compose, download the repository, and then give execute privilege to the Docker Compose and run your Docker Compose CLI commands. Docker space compose followed by the version command here, you can see. Correct.
I have questions. I means the enterprise level, we need to install this all the things, or what means it's already installed?
If you are administrating, you're responsible to install it.
Admin means DevOps admin, or what means?
Yeah, of course. DevOps admin. Developers will not do such installations. Okay, like we DevOps team will use some automated scripts to install it. If you want, you can able to run all these things the shell script, correct? Possible, no? If you save it as a script
Yeah,
file.
yes. Yeah. We need to
Yeah.
create one file for that one, yeah. For that
Yes, it should be fine. Yeah, it will execute there. Easy?
Yeah. Yes, right. Carry on.
Fine, fine. So this is how we install and configure the Docker Compose plugin. To install and configure Docker Compose plugin, the only prerequisite is you should have your Docker engine installed On top of that only you can able to run it. So once this is ready, the next step is, as I said, we have to prepare the manifest file that is going to define the properties of the service and its containers. So I'll give you one small example here, like just look into the scenario. So this is a simple manifest file. It starts with the version, API version, and services with the name. Like here we have web serve 1 and its image along with the port number, and the DB serve 1 along with the image. So it means I'm going to create one service, and this service is going to execute two containers. The container name is web serve 1 and DB serve 1. These are two containers which will get executed as part of the service, and web server's image is Tomcat and its port mapping. Similarly, database server, I'm going to use Redis Alpine. So this is how we just maintain our container definitions as part of a service. A very simple example. So this is just to make you understand or aware of the process, how we can use this doc compose file to prepare multiple containers. And once the file is ready, you can simply say docker compose up command to start all these containers as a service. And if you say down, it will stop all the containers, exit from all the containers. All right. And if you can see the syntax of this file, version colon followed by the value. Similarly, the services, these are the definitions. So that's what we call as the keys and values. We have a key and its value. Clear? So it is just an example. I'll be showing you all these things in detail once we start with our Kubernetes module. Any question on this? Okay, so let's create a file, and the file name should be exactly same. Okay, the docker -compose. So here I can create a file. Sorry. So I'm going to create a file here. File name is docker-compose.yaml file. Go to insert mode and you can save this content there. That's it. So any manifest file that you write using YAML, it is based upon. So this is the key and its value. It's a API version actually. And then the services, within that we have two service definitions. Each will be having its own image. So you can assume this as one container using Tomcat image with the port mapping, and this is another container with Redis Alpine image. Alpine also is a kind of your OS distribution, which is very lightweight when compared to Ubuntu and all. So let me save this file. And once the file is ready, from the same path where you have created a file, you can use a command called docker compose up command. Docker compose up. So when you say docker compose up, see what is happening. It is running the service. It is creating content out of the service. See, it has created a Tomcat and then it has started the Tomcat service, right? And also the Alpine. So if I use my duplicate terminal, and if I say docker ps, see, it has created two containers now. One is with Tomcat 8.0 and another thing is Redis Alpine. Just 27 seconds ago it started, and it has performed port mapping also there. Easy. So this is the name of that particular container. So like this, if you want to start n number of containers. Like this is container 1, this is container 2. So like this, you can able to create n number of containers just with a single command, docker compose up command. Because in a production level implementation, if the containers are depends upon each other, like we cannot simply run your Tomcats container because this service includes your user interface and database. So these two containers should be started at the same time and it should be up and running at the same time. That's what happening here, right? And once the process is completed, you can use docker compose down command. So sorry, I think there is a issue. Let me execute this command of compose down. So when I say docker compose down command, you should be able to see all these things. What are the configuration of the containers we have created? Everything will be down at the same time. So what is the purpose of this down command means? What all the containers will start at the same time, everything should be stopped at the same time, correct? Can you see this? It is stopping and it is stopped here. Now if I say docker ps, nothing is up and running. You see? So in a real-time environment, if you want to run multiple containers, if you want to start multiple containers at the same time, you can use this docker compose. But I'll tell you the ground reality. In real-time environment, we are not going to rely on this docker compose. The use of docker, it will be till you publish your image to container registry. Correct. So we are not that much, using this docker compose because of various, reasons. So I'll talk about that now. So we use one term called Docker Swarm, right? So what is a Docker Swarm? It is used to ensure high availability of your containers. You can take the same example here. Assume that I have these 3 containers. So consider using Docker Compose. I'm executing all these 3 containers. All these 3 containers are up and running now. But due to some reason, if this particular container is not responding, let's say due to some business logic error or any impact, okay, your container is not responding, what will happen? What will happen?
The service is not going to work.
It will impact the entire service. That's the point. Whenever there is a dependency, when you run all these containers as a service, even if one container is down, it will impact your entire service, right? So then how we can able to ensure high availability of the microservice? For that, we use a concept called Docker Swarm. So Docker Swarm, it is the main objective is to ensure high availability. So how it will do means it creates replicas of container, or I can select containers. It creates some replicas of the containers. Say for example, already I have 3 containers. Out of these 3 containers, if one container is down, I'll be losing my entire application. So what I can do here is, while creating the container itself, I can create some replicas of the containers. So there is a command like replicas equal to 3 or replica equal to 5 means it can able to create 3 replicas of your container. Let's say I can tag it as like this. So what it mean? What it can understand from this?
This container is not working, so other container will work on that service, yes?
Yes, so it is something like we talked about the environments right in our previous cases. When we talk about the environments, we never have one production server in the production environment, right? Production environment means it's composed of production servers. More than one server will be there in production environment, correct? Why we create more than one servers in production environment?
If the service will be down, so other
Yes,
service
even
will be
if
up.
one VM or one server is down, I can have the backup server to ensure high availability. Same concept in containers also. If the containers are used to maintain your production workload, especially in production environment, if you want to deploy this container, do not deploy only one container, just create some copies of the container and deploy it. We'll be creating some replicas of the containers and it gets deployed there.
So
Right.
this container will
So
be working as a simultaneously means.
yeah, that is what the point here. So how many replicas you create? Replica means what? Just like image copy, right? It's just a replication of the container. So what are things you are running here? It will be deployed 3 times. So you are not going to deploy one instance of your application. You will be deploying 3 instances of your application. Correct? So using your Docker Swarm, we can able to create some replicas of containers and we can able to deploy it. So even if one replica or one instance is down, I can have other instances to support my application. And there is another important thing here. On what basis we decide replicas? It is purely depends upon the number of requests, like how much user request we can expect on the particular service. Depends upon that analytical data. We just define the number of container instances. So let's say, for example, for my current business, I am expecting around 300 users to simultaneously access my server or application. So to support 300 users, I assume these 3 copies of containers are more than sufficient. All people can able to parallelly access these containers and they can able to execute the service. But all of a sudden, if the 300 becomes 3000 due to some network traffic or more users trying to access your application, do you think the same replica count is sufficient for that?
No.
No.
Initially, I've created replicas to support 300 users, but due to some reason, there is a huge traffic in my network. So the 300 becomes 30,000 users. So if all 30,000 users trying to access my application, they'll try to give a call or hit to this container. So definitely the container, 3 instances of container cannot be possible to support your application's availability, right? So we have to add more container instances there. So that's what we call it as a scaling. The container instances. Right. So scaling in the sense it can be scale up or scale down. Great. Scaling means that's what it can be a scale up or scale down actions. And how are you going to scale up or scale down? Are you going to do it manually or automatically? All of a sudden, my application traffic is very heavy. So during the time, should I go and manually add the number of container instances, or I want that to be automated?
Automatic.
Automated. It has to be automated.
So there should be a system, right? The container orchestration, whatever we're using here, the Docker Swarm for this matter, the Docker Swarm should be intelligent enough to identify the traffic, identify the health state of that container, and if this container health state is not sufficient to support application, it should automatically scale up. And if the traffic goes to normal state, it should automatically scale down, correct? That is the explanation, right?
Yes. Mhm.
But the problem is your Docker Swarm is not capable for that. No auto scaling. Your Docker Swarm cannot support auto scaling. If you want to scale up, you have to manually again go and read the file, add some number of replicas and save it again. That is what the scenario in Docker Swarm. First point. Second point is we have something called load balancer. Load balancer means in a real-time environment, you can create some number of container instances. Do you think all these 3 instances will be deployed to one production server? Consider I have a production server. I have prod server 1, server 2, and prod server 3. So I have 3 production servers in my production environment, and I have 3 instances of my container instance. So during the deployment, the containers should be distributed in more than one production server, right? That's what load balancing. Great. Even if one node is down, it should be deployed to other available node. So that is how the load is equally distributed with more than one node or the worker node target server. But this capability also is not present in your Docker Swarm. So Docker Swarm is not capable to perform auto scaling or load balancing. It is completely manual effort. That is what the maturity model of your Docker. Okay, if you compare the Docker, right, or if you see the evolution of your containers, as I said, is not something new. It is there in place for many years. Docker was introduced in the year 2013. Okay, 2013 it was introduced, and it took around 2 years. Okay, around 2015 it gained its popularity. Okay, and most of the organizations, they started to use Docker because using Docker we can able to quickly create an image, we can directly push it to the container registry. A lot of benefits are there using Docker. It's a very good and very easy tool when compared to other container orchestrations or container tools. Like before Docker, we were using Linux containers. We have a dedicated Linux container. It is also same as like a Docker, but it is not that easy as Docker. Got it? So most of the organizations, they started to adopt to this Docker containerization. If they want to containerize application, they were using Docker. Like this, most of the organizations, they started to adopt to this one. But over the period of time, they faced the actual issue. That is, just with Docker, we cannot achieve anything. We need Docker Compose plugin to run multiple containers as a service. So they installed Docker Compose. Now, the next level, in order to implement a production environment, my expectation is, so far I'm doing it manually, but at least using Docker, I want to automate the process of auto scheduling and load balancing. That's the expectation, but that is not possible with Docker, right? So how to overcome these issues in Docker? It is not possible. That is the reason we use something called
Kubernetes.
Kubernetes, the hero introduction. Okay, so now the Kubernetes also, it is a container orchestration tool. You can call it as a open source now. Open source container orchestration tool. And what is the need for Kubernetes means? It is also used to ensure high availability of pods. Correct. So when I say pods, as of now, just keep the term in mind. You can compare it with the container. So far in Docker, we use a term called containers. But when you try to deploy it in Kubernetes, we never use a term called container. We use it as a pod actually. I'll talk about the pods, everything once we start with the Kubernetes module. Now, it supports auto scaling and load balancing. Okay, and able to handle or provision huge volumes to execute containerized application services. Got it? And another important property here is self-healing. Self-healing in the sense, consider I have created 3 instances of my container. Just 3 replicas of containers it is created by creating pod instances. Pods, I can say like this. So high availability can be ensured using your container pods, and how it is going to achieve high availability means by using the replicas of the pods. Here also we're going to create some replicas of pods actually. Pods and replicas, pods and containers, as of now you can consider it the same. Right? In Docker world, we use a term called container, but in Kubernetes world, we call it as a pod. Pod is a collection of containers which can be deployed in Kubernetes. Okay. Now, consider I have created 3 replicas of pods. So what it means, at any point of time, I want 3 copies of pod should be up and running. Whatever situation it is, if I say 3 replicas means I need 3 copies of pod should be up and running. Okay. But due to some reason, one instance of that particular pod or container is not working as expected. So if you're using just a Docker means you have to manually, heal that. You have to delete and, to add more things through Docker Swarm. But here in Kubernetes, we have a concept called self-healing. Kubernetes will continuously monitor the health state of that particular pod instances. If any pod instance is not at the expected health level, it will immediately create a new instance of the pod, replicas of pod. That is self-healing means. So I'll show you how all these things happens. We have something called Kubernetes controller objects. Through that, we can able to achieve it. All right. So important thing here is Kubernetes, which we are going to use here is an open source Kubernetes. We are not going to deal with any managed services like Elastic Kubernetes service or Azure Kubernetes service. Here you'll be learning only about your open source Kubernetes. Right. Hope you can understand, right? What is Docker Compose, what is Docker Swarm, and then Docker and Kubernetes. So once you start with Kubernetes, you never use Docker Compose. It is not required because through Kubernetes, we can able to run multiple containers as a pod. And then here we'll be using your, what do you call that? The open source Kubernetes. So it means, let's say, for example, I have some number of containers that are deployed in a production environment. Okay. And if it is deployed using Docker means the amount of data that is required for the container, how you can pass it? You can pass it through some Docker volumes, correct? Using Docker volume, you can able to share some input files or save some output files from the container, correct? We did it last week. Last session.
Yes.
So the Docker volume, whatever we created, it is created within your local machine, correct? The build server. But
Yes.
consider I have an application service. To run that application service, I need around 500 GB of volume. So that 500 GB of volume, I cannot create or use it from my existing environment. I need to procure it from the external storage server. It can be your EBS volumes or EFS volumes, or it can be your Azure disk or Google persistent disk, or even it can be the users, on-premises storage server. So whenever you want to access or allocate a huge volume of storage, you cannot rely on Docker Swarm. For that, your Kubernetes would be the right option. So in order to manage some transactional data and its entries, we'll be using the Kubernetes persistent volume. All right. So these are some properties actually. Just keep these properties in mind. Okay. Anyways, we will learn about Kubernetes in detail. All right. So if you have any questions so far, please let me know. Want to have a quick break of 5 minutes? Yeah, no problem. Go ahead.
Sure.
Yeah.
So now looks like, seems like this Kubernetes is more in demand in comparison to the Docker Swarm.
Now means from when?
Not sure from when you are into this industry for so long. I'm not sure, but whatever you have been saying so far, it looks like that people are using or relying on Kubernetes more than the Docker Swarm.
Yes. We use Docker to create the container images, and we use Kubernetes to deploy those container images. We never use Docker Swarm or Docker
Docker.
Compose.
To deploy
So
these container images where?
Target
register
environment.
it. Okay. So looks like only till we get we what publish it to registry, we
Contain
use Docker.
Docker. Yeah.
Docker.
And
Then later part, the pulling of the image and everything is done by Kubernetes, using Kubernetes only. Yes.
yes, that's right. And in Kubernetes also, we are going to write some manifest file to define the properties of the containers and pods, but we never call it as a Docker Compose kind of thing. Here it is just a manifest file. It can be written using JSON or YAML format. I'll show you. I'll talk about it. Yeah, go ahead and come, please.
So Sai, hello.
Hello, Luke sir. Hello.
So where we are?
Hello, sir. Can you hear me?
Yes, I can.
I have one doubt, sir. Actually, creating replicas of the containers, sir.
Come again?
If you create manually, like same kind of containers, what?
Uh, sorry, I'm not able to hear you.
I mean, you're saying replicas of the containers, right? I mean, C 1.1, 1.2, 1.3, right?
Could you please be louder? There are some background noises actually.
Now, can you hear me? Now?
Yeah, tell me please. Louder. Huh.
So actually, you told that creating containers, right? Replicas of container C1
Okay.
1.2. So we need
Okay.
to create manually that same duplicate containers.
Yeah, that is no. Duplicate containers can be created by your Docker Swarm. Docker Swarm can able to create the replicas.
Okay, okay.
But if you want to auto scale, if you want to scale up or scale down, that alone is not possible. I mean to say here.
Oh, so that Kubernetes also can able to create the replicas automatically.
Kubernetes also can able to create the replicas.
Okay, okay, got it.
Truly right, by creating replicas of pods. In
Yeah.
addition to that, it is capable to auto scale.
Okay. Okay, got it. And see, meanwhile, I'm seeing nowadays positions like Kubernetes administration, Kubernetes administration.
Mhm.
For them, only Kubernetes can do, right?
Yeah.
1 minute, I'm sorry. Hello?
Yeah, that's right. Only Kubernetes.
Yeah, okay, okay.
Sai?
Yes.
So, I think day before yesterday we installed this Docker in slave node, right? So even the Kubernetes will be installed in slave, or
No. No. It is a separate architecture. I'll talk about the installation of Kubernetes, all those things separately. It is a separate topic. Once we start with the Kubernetes model officially, we'll talk about it.
And one more thing, Loksai, you just mentioned in the second line that Kubernetes ensures high availability of the pods or containers by creating replicas of pods. So pods is a collection of containers.
Yeah, you can consider pods a collection of containers.
Okay. And it creates the replicas of pods instead of containers
It means it creates replicas of the containers in turn.
inside the pods.
Yes.
Okay, like C1, C2, C3. And I'm considering this IMG1 as a pod. Pod 1, C1, C2, C3.
Another replica, another copy will be having another 3 set of containers. Like that, it creates replicas.
Okay. It's a collection of containers.
See? Any question?
No, not as of now. No.
You will show na, how to create replicas in Kubernetes.
Yes, Kubernetes is a separate module. Okay, we
Yes.
haven't started that module officially, but once I start that module, I'll talk about your Kubernetes module and other stuff in detail. Okay, don't worry about that.
Okay.
It is my area of specialization, so don't worry. I will share. But we are limited to your curriculum. So what are things required? I'll be sharing it according to your scope. And but before that, I want every one of you to be comfortable till Docker publish. You should able to create a container image and publish to your container registry. Is that possible?
Yes.
Yes.
Okay. So, and you understood the purpose of Docker Swarm and Docker Compose, right? Correct?
Yeah.
yeah.
Okay. And using Docker Compose, we can able to create multiple containers and
We
run
can
as a
deploy.
service. But Docker Swarm is something used to ensure high availability of those containers. Correct. And another important thing is using your Docker Swarm, we can able to run only your Docker containers. For example, here I'll add that point also. Swarm is limited to Docker containers only. It is a product of Docker, so it is meant only for Docker and orchestration. But apart from the lot of other containers available in market, like we have Linux containers, we have Podman containers, a lot of things are there. To orchestrate all those things, we can use Kubernetes. Kubernetes is common, okay? It can be used by any of your for any container for that matter. And if you consider the process or evolution of this Kubernetes, right? So actually, this Kubernetes was created and owned by Google. Okay, it was actually the product of Google. It was a proprietary product of Google. I told you right, in 2013 Docker came into market, and by 2015 most of the organization they started to use Docker for their containerized workload, everything, because of its easy way to create an image. But when they try to use the Docker for their production workload, there they found a very major issue, that is Docker Compose or the Docker Swarm. It is not capable to handle the production workload. Docker Swarm is not capable to handle production workload. Because when it comes to production, right, we have thousands of microservices. Like if you take Amazon.com or your Facebook or Netflix, it's all containerized applications. So any such containerized application, if it is running production environment, it has to execute thousands and thousands of microservices in parallel. Okay, and each and every microservice has its own resource requirement. So a Docker Swarm is capable to run multiple containers using Docker Compose integration, and can able to create some replicas of pods, but it is not that much capable to handle the production level workload. That was a very big issue during 2015 and all. Most of the organizations, they were struggling to handle the situation. Correct. But by that time, Google, right, they were using Kubernetes. Even before Docker came into market, Google was using Kubernetes to deploy all their services. The Google search engine, the Google Maps, and all the Google services, they were creating and containerizing and deploying it through Kubernetes. They have created this product and they were using it only for their own service deployments. Even before Docker came into market, that is before 2013, Google was effectively utilizing Kubernetes product. And when the global customers started facing the issue of Docker Swarm, right? They can't make it in production environment. So during the time, they found the Kubernetes was the very effective tool, which is something owned by Google. And Google came forward and released their own product to the open market as an open source tool. Correct. In 2015, by the time they just released this Kubernetes proprietary product to open market and release the open source version of Kubernetes. When Google released that product as an open source product, other service providers like your Amazon, AWS services, and Azure, and any other service provider you can see, right? So they just use that open source Kubernetes and created their own version of it. That is what we call it as Elastic Kubernetes Service. Correct. The Elastic Kubernetes Service or Azure Kubernetes Service, which we are using in the cloud platform, which is a managed service. It is actually from the open source Kubernetes only. It's possible, okay, anyone can able to use the open source and add more features and release as their own product. It is possible. That's why it's called as open source, right? So most of the organizations, they can use open source Kubernetes to deploy the productionized workload by enabling auto scaling, load balancing, self healing. They can able to use it. That is how the process is actually. And in this training module, we're going to learn about open source Kubernetes. Tomorrow, once you start with your AWS or Azure, there you'll be learning about your managed services like Azure Kubernetes Service or AWS Kubernetes Service. Understood, right? This is the background of this Kubernetes. Any question?
Yeah. So the evolution of Kubernetes is pretty much like the evolution of Linux flavors, right?
Not exactly.
No, because that is also an open source operating system, and it is a tool. It's a difference, I know, but uh, people have used the base of that Linux, and they created their own distributions. And similarly, Azure and AWS.
See, it is not just about Kubernetes, okay? Any open source tools available in market,
Hmm.
you can able to utilize it. Okay, it is not just about Linux. Okay, you have Linux, and based upon Linux, you have your uh, distribution like Ubuntu or CentOS, right? Again, it is available for free, but your EKS and AKS is not free, right?
Okay. Hmm. Yes.
So using your open source Kubernetes, you'll be learning about the features and capabilities of Kubernetes. We'll see all the core concepts of Kubernetes first, and I'll show you how to use your images and deploy to Kubernetes cluster. So as part of your course curriculum, if you can see here, we are done with the Docker and we'll be starting with the Kubernetes actually. I can start it from
Let's
tomorrow,
say
okay?
one question here.
Yeah,
Are we not going to see Docker volume?
we did it right.
Yeah, we did it yesterday or day before yesterday.
Okay, fine, fine.
So as part of this Docker module is concerned, ensure that you are clear with your core Docker terminologies, like what is a container, what is an image, what is a container registry, what is a container engine, what is a container repository, right? And then you should be clear with all your Docker CLI commands, like the day-to-day commands, whatever you used. And especially you should know all three types of Docker run commands, run mode, and your Docker image creation process using your Docker compose, sorry, Docker commit and Docker build. And next thing is about your port mapping. Port mapping and all, right? We'll be doing the same concept in Kubernetes also. In Kubernetes also, we'll be talking about it, but it will be in a completely different perspective. I'll show you how to work on it. It is also used to expose your pods to internet. Correct. We usually use a term called pod in Kubernetes. In Kubernetes, we never use a term container. In Docker world, your applications are packaged and execute as a container. But in Kubernetes world, your applications are packaged and execute as a pod. Only the terminology varies. Correct. And also here you should know how to handle your registries, Kubernetes, I mean Docker registries. Image, whatever images you have created, you should be able to push it to your container registry. Correct. And then what is Docker Compose? How to create your manifest file to define multiple container and execute as a service. You should know how to install Docker Compose and start deploying your services there. And then your fundamentals overview of Docker Swarm. What is Docker Swarm and how it is different from Kubernetes? That's what we discussed now, right? Any question so far?
No, not as of now.
Is it clear to everyone here? All silent audience.
Yes, sir.
Thank you.
And for this
So
manual installation of, scroll up please. This one, Docker Compose. We just need to copy these commands and we need to run them
yeah,
one by
that's
one
right.
each.
That's right. Okay, fine. So what we are going to learn in Kubernetes means, as per your list, we'll be learning about I think we talked about the difference between Docker Swarm and Kubernetes. I'll talk about the architecture. For any Kubernetes resource, Kubernetes architecture plays a very important role. You need to be very clear about the architecture of Kubernetes and the components of the Kubernetes architecture. Kubernetes is basically a kind of a client-server architecture. You'll be having a Kubernetes master node and the worker nodes for deployment. I'll show you how to create this Kubernetes nodes and how to install Kubernetes. What are all the various methods to install Kubernetes? I'll show you. And then we'll see how to create a Kubernetes pods, how to deploy it, how to upgrade your services, how to scale up or scale down the applications, services in Kubernetes. Here also we'll be learning about the volumes, Kubernetes volumes. Like how we discussed about Docker volume, here we have a concept called a host path volume. Right? We'll talk about it. So yeah, I can start this from tomorrow. Already we talked about the differences. If you have any question, let me know. So ultimately, what is a container orchestration tool? What is the purpose of container orchestration tool? Whether it's Docker Swarm or Kubernetes?
Auto scaling, self-healing, load balancing.
Okay. So ultimately, it is used to ensure high availability of your containers,
Yeah.
right? When you deploy your container in Kubernetes in your target server, how much it is available, right? So that is something ensured by your container orchestration tool. Easy. And in today's scenario, any microservice applications are deployed using Kubernetes. And we have good requirement for Kubernetes also. And then we'll be having Ansible and Terraform, Prometheus. So 4 modules. Okay, super. Yes, so I'll give it for you now. Any questions, you can ask me now.
So any service which is running in any microservice based application architecture, they are assigned with their uh, specific container. Each service is assigned to a specific container or pods.
Not like that. Each service will be having its own pod.
Mhm.
Pod means not one pod. Okay, there'll be more than one pod. I talked about your, if you can see my example here, listen. Here, I was giving this reference, no? Like for this 3-day application architecture, there is one microservice to perform user login process. So this user login service is having 3 layers of your application. In Docker world, each and every layers are deployed as a container, correct? In Kubernetes, it will be deployed as a pod. This is pod 1. This is pod 2, pod 3. Like that, we'll be deploying it. Right? So once you start working on that architecture, there you will get a clear picture why we use the term pod, why not container. It's a lot of difference, key difference are there. Let's talk about it during your architecture.
And maximum we can have just 3 layer for a 3-tier application architecture.
Okay. Yes. So yes, that's right. So I have uploaded here. And yes, it's done. Cancel it. Yeah. Any other questions, guys, from anyone?
For
Any
working
question?
in any of the project, all these tools will be related to each other. We will use everything at the same time. Like for example, in Jenkins, we are using like Git, Maven, and so you if you are running a project in the organization, I'm asking for job prospectus. So all this will be correlated for pushing and some image downloading or doing something. We will use different tools.
You're talking on DevOps perspective or
I'm talking on DevOps perspective.
okay. So if you're talking on DevOps perspective, don't get confused with all these tools. Okay, as a
Okay.
DevOps resource, just go back and focus on these things. We talked about what is DevOps and
Yes.
how to implement DevOps and what are all the stages of your DevOps, starting from the continuous development till continuous monitoring, right? We have various stages.
Yes.
So you'll be working on these stages only. Depends upon the stages only, the tools will be decided. For
Okay.
example, consider a scenario. I have a customer, they are developing a Java based application, but they're not using any container technology there. Artifacts, whatever they create, they just want to deploy to the target server. Correct. So for such customer, do you expect Kubernetes?
No.
That matters. But we work on all these stages. We do continuous development there. We do continuous integration. We will automate the continuous testing. We'll automate the continuous delivery deployment, right? Through Jenkins. Only
Yes.
thing is your Docker or Kubernetes will not be there. Correct.
Right.
Few customers, they will be doing their uh, continuous delivery and deployment using some other orchestration tool. Like currently we were talking about Jenkins. Apart from Jenkins, we have many other tools like GitLab CI or GitHub Actions or Azure pipelines or AWS Code Pipeline. A lot of things are there. So if the customer is using GitLab CI, means you have to create your CSD pipeline using GitLab CI tool, not Jenkins. Correct?
Yes.
So by going through all these modules, right, don't get into a pressure like we have to implement everything. It's not like that. First
According
of
to the
all, you need to
requirement.
understand. Yeah, you have to understand their customer base.
Okay.
You have to. That's what. Even I would have given you one important pointer. Yeah, right. So how we can implement it? What are things we do there? So we'll be doing a detailed assessment of your DevOps requirement. We'll understand the customer's requirement first. Based upon requirement only, we'll be deciding which tools to be used. Got it? So
Yes.
it's a very simple job actually. Don't worry. So any other question, guys? Are we good with this? I uploaded the content here and okay, details are available in the document itself. You can take it further. So in tomorrow's session, we'll see how to work with your, I will start with the Kubernetes. Yeah, tomorrow we'll spend a lot of time in understanding Kubernetes architecture and its components. Once you're clear with the architecture, then it's easy for you to work on that. Yeah, what is that question? Come again, someone? Oh, Paul is missing. Yeah. All right, guys. All good?
Yeah.
Okay, sir. Thank you. If you don't have any question, then can, yeah, you can log off. We'll connect tomorrow. Thank you all.
Thank you.